Hello everyone. Our first de Broglie calculation is going to involve a proton. This one's a pretty straightforward question where you're given the energy and you need to determine the wavelength. Since they're referring to a proton, we have a few numbers we can get off the data sheet. If we need charge, we know it's 1.60 times 10 to the negative 19 coulombs. If we need mass, it's 1.67 times 10 to the negative 27 kilograms. We want the Broglie wavelength, and we have its energy equal to 2.42 times 10 to the negative 4 mega electron volts. Now that's not in the right unit system, but we'll convert that when we go to our formula. We know that de Broglie wavelength from our notes, wavelength equals h over mv. So if we can figure out the velocity, we can then figure out the wavelength. So what I need to do is I need to go and find out from energy what its velocity will be. So if I have the energy, and remember this formula requires energy to be in joules, so we've manipulated this one quite often. 2 times the kinetic energy divided by the mass square root equals velocity. I'm going to do that down at the bottom here. 2 times 2.42 times 10 to the negative 4 mega off your data sheet is times 10 to the 6 electron volts. We also have to convert times 1.60 times 10 to the negative 19 joules per electron volt. We have to get this in the right unit system. Kinetic energy formulas are always in joules. Divide by the mass of the proton, 1.67 times 10 to the negative 27 kilograms. Take the square root. That'll be equal to the velocity. So if we punch that in, 2 times 2.42 to the exponent negative 4 times 1 to the exponent 6 times 1.6 to the exponent negative 19. It's my numerator. Divide by 1.67 to the exponent negative 27. Take the square root of that number, and you get a velocity 2.16, this is a rounding, times 10 to the 245 meters per second. Now what I can do is put that in the de Broglie formula, which I'll do on the next slide, to determine its wavelength. So be careful. Remember that energy formulas always work with joules. That's one of the biggest mistakes students make. Convert all the energies into joules, then find the velocity, then find the wavelength. Now you could have done this as one single formula, but it gets pretty messy. That's why I broke it into 2 pieces. So if you go to the wavelength equals h over mv, wavelength equals 6.63 times 10 to the negative 34 joule seconds divided by 1.67 times 10 to the negative 27 kilograms times the velocity 2.15 times 10 to the, I think it was 5 if I remember, times 10 to the 5, 2.16 times 10 to the 5 meters per second. I'm going to keep that exact value on my calculator. So I'm going to multiply that number that was still left on my calculator by 1.67 to the exponent negative 27. Then I'm going to take 6.63 to the exponent negative 34, divide by that, and I should get a wavelength for the proton equal to 1.84 times 10 to the negative 12 meters. And that is a reasonable wavelength. The electrons were in the neighborhood of 10 to the negative 9, 10 to the negative 10. Protons being a little slower and more massive should have even a smaller wavelength, 10 to the negative 12, closer to the gamma region rather than the X-ray region if you're comparing to an EMR. The bigger the object, which we saw in our notes, the smaller the wavelength will be. So the proton being 2,000 times or about 2,000 times bigger than the electron, but it also travels slower, works out to be about 10 to 100 times bigger in terms of, 10 to 100 times smaller in wavelength.